Samir Yadav, can you make it full screen, please?
Now, I would like to request sir, welcome our yes.
This happened for the first time like this. Morning, Jitendra. Good morning, Puskango.
So much, sir, and welcome everyone. Now, thanks. Now, I would like to request our director, sir, to please deliver his welcome.
On behalf of entire CSIR-CBRI family, I warmly welcome all the panelists to this panel discussion on tools to resilience. And also, I wholeheartedly welcome all the participants. So today, I Krishna Vatsa sir, member NDMA, Professor CSIR-Murthy, IT Das, Professor Indra Singh, IT, Professor B. from IT Madras, Professor Goswami from IT Madras, and Mr. Arun Kumar, Director of PIS, and Mr. Jitendra Kumar from PIS, Dr. Hari Kumar, Geodars International, from World Bank, and architect S.K. Negiji from CSIR-CBRI, and Dr. E.P. Kanungo from CSIR-CBRI, and Dr. Ajay Chaurasia from CSIR-CBRI. So let me first do the background setting of why we are doing this event. As you all know, that in 2015, so there were two earthquakes, two massive earthquakes. One occurred on 25th April 2015, which was of 7.8 magnitude in Gorkha region. So the death toll during that earthquake was around 9,000 people, and around 25,000 people were severely injured, and many, millions of people got displaced. And all the agencies, international agencies, including Nepal and India, has also sent a team for doing a quick reconnaissance survey to understand the extent of damage and what to do after post-earthquake. So during that time, a team led by Professor CSIR-Murthy, in which the members, like 500 members who are sitting here on the dais, either physically or virtually, were present. In that, Professor Yogendra Singh and Dr. Hari Kumar and Mr. Anup Karant, Arun Meenar, Dr. Ajay Chaurasia, and me, we were present. So we were doing reconnaissance survey, and after 4 days or fifth day, this another earthquake occurred. That is May 12th. So that was of 7.3 magnitude. So which was considered to be aftershock by many people or a fresh earthquake. So, but these two twin earthquakes have given a lot of lessons to learn. One is it's very long period waves, and lot of heritage structures got damaged and collapsed, leading to a lot of death toll. So today we are commemorating this event because 10 years have passed. So from that day onwards, 2015 onwards till 2025, what we have understood. So what we have in terms of technology, in terms of knowledge, more importantly in terms of implementation, how we have improved. So that's why the title, the apt title, that is Ruins in 2015 to Resilience in 2025. So, luckily, Government of India has given a big support to Nepal's reconstruction, and CSIR-CBRI has played a major role in the reconstruction of two important sectors. That is, one is education and health sector. So details of that will come very soon. So first is rapid field assessment and the extent of damage survey, the capacity building, and then challenges in implementation, international cooperation, and also how to maintain resilience in public infrastructure, and what are the long-term lessons learned through this earthquake and the activities after the earthquake. So all these points will be touched upon by our panelists. So first of all, what I would like to do is I would like to call Dr. Ajay Chaurasia, who was a PI for this Nepal rebuilding project along with his entire team. So I first request him to start with the overview of Nepal.
Mr. Vijender Singh from IWP, Mr. Antikaran from World Bank, Mr. Arun Kumar and Jitendra Ji from BIS, uh, my colleagues, Dr. D.P. Kanungo, Negi Ji, and Mr. Hari Kumar from CSIR, colleagues from CBRI, online officials from Ministry of External Affairs, Government of Nepal, and over 200 participants online joining for this particular panel discussions. Ladies and gentlemen, good morning. Namaste, pranam to all of you. The devastating wind earthquake that struck Nepal on 25th April and 12th May 2015, measuring moment magnitude of 7.9 and 7.3 respectively, left a deep and lasting impact. These tragic events claimed thousands of lives, injured many more, and severely damaged the country's built environment. Our thoughts remain with the people of Nepal, and we extend heartfelt condolences to the families who suffered irreparable losses. The road to recovery has been long and arduous, but it has also been a journey of resilience and solidarity. The earthquake caused widespread destruction of habitat in Nepal, thanks to NDMA for competent Indian engineers for post-earthquake regional survey. So damage are here under. These losses not only disrupted essential services, but also posed significant challenges to the safety, well-being, and long-term development of affected communities. Recognizing the urgent need for technical sound, seismic is safe and appropriate reconstruction. CSIR building itself will take a good deed. Under the aegis of India, a major initiative assists Nepal in rebuilding its education and health sector projects. This endeavor focused on integrating sustainable construction practices and community-centric construction. So, through collaborative planning, design innovation, and on-site implementation, CSIR-CBRI has contributed to the construction of safe, durable, and functionally efficient buildings that now serves as a lifeline for Nepal's post-disaster recovery. that CSIR-CBRI has undertaken planning, designing, and construction of study. But this is so this particular event has been taken up. Basically, the backdrop has been led by Professor Pradeep Kumar Ji, the CSIR-CBRI. So this particular event was unusual in terms of intensity, duration, and natural periods. It has both affected 14 as against that the development of and health sector in the state of project was centered on the area in both sectors combining together. Students are benefited annually. Over 5,000 medical staffs have been employed. Over 1,000 teaching staff have been employed. And the biggest hospital and biggest library has been constructed as per CSIR design. Since the task was enormous, so that's why the type design model was adopted. And over and above, the online monitoring was done online and offline for the construction of different projects. The challenges were numerous. First of all, there was a very time shortage in submission of the DPR. The challenges was in terms of multi-hazard. So, building the need assessment study by the CSIR-CBRI, here's the challenges of landslide, tides, and excessive rainfall over and above in the remote locations and very difficult terrain. Above all, CBRI has taken, this was a really roller coaster study, and then this. So thanks to CSIR-CBRI team for their devotion and enriching experience which has been imparted in this particular project. And as a result, within 45 days of the time from the start of the project, the DPR has been submitted to the government of India and government of Nepal. And as a result of this particular project, all the papers have been conceived with three important objectives as integrated facilities, use of appropriate technologies, and boundary conditions in compliance in providing efficient functionalities. So these are some of the pictures and have been visualized of the project. It was put on the ground in reality by CSIR-CBRI and government of Nepal and government of India. So during the execution, a stringent monitoring was carried out, both physically as well as online, through rigorous training, capacity building, and compliance to the mandatory requirements. And as a result of that, the team sets of some of the completed education sector projects in different parts of the Nepal and health projects in different parts of the Nepal are shown here. This, we have not only constructed the buildings of concrete and steel, we have also provided all the functional requirements, including the infrastructure in all the projects. At the same time, we have taken the community also on board, and as a result of which, the different layers of different flexibilities Nepal have visited CBRI, and so that the technologies and construction practices can be taken down. At the same time, the government of India have been translated to the government of Nepal and their communities through extensive outreach programs, capacity building, awareness activities. In short, in summary, this particular effort has strengthened the Indo-Nepal relationship, identification of impediments in construction, finding solutions to research, development, and innovation, implementation of the technologies from lab to land, capacity building, technical competence, and moreover, the important part is the advocacy in the society. And to summarize whatever achievements we have done, So I request Professor on behalf of Krishnavati Society much. So this is in this context, the contributions by CSIR-CBRI is documented in the visual narrative titled "Twins to Resilient." Now,
So it was it was a wonderful song that it included. Uh, Now, see, with like Dr. Mickey, the please, sir, first of this presentation. Very good morning to foreign present here. It's my humble duty to introduce the speakers, esteemed speakers of the function. Sri Krishna S. Works. Sri Krishna S. Works is presently working as member NDMA. He has been working in the field of disaster management and rehabilitation for the last 25 years. Prior to joining as member NDMA, she worked as policy advisor, disaster recovery, Bureau of Policy, Program Support, UNDP. He has also served as secretary to Government of Maharashtra, Relief and Rehabilitation from 2003 to 2006. He has worked extensively in the area of disaster risk reduction and recovery. Our second speaker, Professor CBR Murthy, sir. Professor CBR Murthy is professor at Department of Structural Engineering at Indian Institute of Technology, Madras. His research interest is in the area of nonlinear behavior of steel and concrete building bridges. Professor Murthy has undertaken post-earthquake surveys to document valuable lessons after all significant Indian earthquakes in the last 2 decades. He has contributed significant to the revisions of Indian seismic rules for buildings and bridges. Our third speaker for the event is Professor D. Sri Nagesh. Professor D. Sri Nagesh is Professor of Practice in the Department of Civil Engineering, IIT Madras, specializing in the field of earthquake hazard. He previously worked at CSIR-NGRI as a chief scientist. His research interest into seismology, geophysics, focus with earthquake hazard. Our next speaker is Professor Y. Singh. Professor Singh is presently working as professor at the Department of Earthquake Engineering, Indian Institute of Technology, Roorkee. He is also serving as Indian Railway Bridge Chair Professor at IIT Roorkee. His area of research interests are seismic design, earthquake engineering in hilly region, and dynamic response of bridges under moving loops. Our next speaker on the program is Mr. Anup Karam. Mr. Anup Karam is presently working as Senior Disaster Risk Management Specialist in the area of social, urban, rural, and resilience global practice at World Bank Group. He has over 14 years of experience and has led several national and regional disaster risk management projects in Southeast Asia. Mr. Anup works in design and implementation of risk mitigation and disaster recovery projects. Our next speaker of the program is Professor Rupen Goswami. Mr. Goswami is at present working as professor in the Department of Engineering at IIT Madras. His area of research interests are earthquake design, design of steel and architecture, and non-linear response. Our next speaker is Mr. Arun Kumar. Mr. Arun Kumar is presently working as Director Civil Engineering and Head NVC Unit at Bureau of Indian Standards. He is currently heading the NVC Unit of BIS, the Standard Formulation Activity. He is also the Member Secretary of NVC. Next speaker for the event is Mr. Jitendra Kumar. Mr. Jitendra Kumar is presently working as Scientist C in Bureau of Indian Standards. He is the Member Secretary, CED 39, Earthquake Engineering Professional Committee, and CED Cement and Concrete Committee. Next speaker for the is Dr. Hari Kumar. Dr. Hari Kumar is a civil engineer working as regional coordinator for Southeast Asia in CSIR International. Dr. Kumar has more than 34 years of experience in the field of safe shelter, disaster risk management, and earthquake risk reduction. He looks after capacity of engineers and builders to assess and improve disaster resilient construction, assist policymakers in implementing new strategies that reduce disaster risk. In this program, now our speakers of CBRI, Dr. Ajay Chaurasia. Dr. Ajay Chaurasia is presently working in CBRI as Chief Scientist and Head Structural Engineering Group. His area of interest are disaster risk reduction and earthquake engineering. Dr. D.P. Kanungo, sir. D.P. Kanungo is working as Chief Scientist and Head Geotechnical Engineering Group. The next speaker for the event is Architect S.K. Negi. Architect S.K. Negi is working as Chief Scientist, CBRI, and heading Building Planning Division. With these words, I request our Director, sir, to begin the panel discussion. Sir, thank you.
Hello. Am I audible? Online members?
Yeah, yes, Pradeep, we can hear you. Yes, we can hear you.
So now we are beginning the panel discussion. So I have a series of questions. Initially, each panelist will get about 8 minutes of time to put forward their view on the questions. So the questions were already leaked to the panelists, but not to the audience, so that answers are crisp and to the point. So Sri Krishnavatsa sir and name is tied up in another important meeting. So that's why he conveyed all the best for this panel discussion. And also he asked us to give the outcome, brief the outcome of today's panel discussion. Now we start with Professor C.B.R. Murthy sir. So sir, you please give presentation on lessons learned from Nepal earthquake, where we are today. You have 10 minutes of time, sir. Sir, over to you.
Thank you, Pradeep. Is the screen visible?
Yes.
Yeah. Roorkee, can you see me? Can you see the screen? Can you hear me?
Yes, sir.
Okay. Good morning, everybody. Welcome to this special day to remember the lives lost in the 2015 Nepal earthquake and pay respects to them and collect the lessons or recollect the lessons that we have learned in the last earthquake and also what we have done in the 10 years interim from then on till date. What I'm going to speak is a collective discussion outcome of all our colleagues who visited Nepal um, immediately after the earthquake in different teams. And so I would want to share with you the three segments of our discussion or my presentation today. First is that earthquakes teach lessons, and second is that 2015 Nepal earthquake is unique, and third is that what did we do in the last 10 years. So first off, earthquakes teach lessons. In the last 140 years, the subject of earthquake engineering, earthquake safety, earthquake disaster management, earthquake risk reduction has grown significantly, and we have collected many lessons. But what is crucial is that many lessons we have not collected yet. For want of time, I will not dwell into that, but at a later occasion, we will document this and share with the audience. I'll go directly to the second point, which is the 2015 Nepal earthquake. We say that it is unique because of a very special feature that it had unearthed for us, which we hadn't experienced before in a major earthquake. So this event took place in the classic interplate boundary between the Eurasia plate and the Indian plate. And a significant segment of that interplate boundary, the subduction segment, gave way. And this is where we are. The 1934 earthquake had slipped a little bit, but what we saw this time was much larger size of slip, extending over about 200 kilometers. Now, this brought out many issues for us. And another concern in this is that we are seeing that the segments are breaking independently. So there are some more segments which have not broken yet. And for them, our worry will be that, for example, if you look at the Indo-Gangetic plains, there are site periods which have been measured after the 2015 Nepal earthquake because of the instrumentation that we had in that region on the Indian side. And we could see very clearly that the site periods are varying from about 3 seconds to 8 seconds. And we are 2 seconds to 8 seconds. So we are looking at structures which have natural periods in this window are likely to get affected during the major event should the event recur in the same or a different segment along the interplate boundary of the India-Eurasia plate junction. Just to take you specifically what we learned, one precise point I want to highlight. When we look at the ground motion in Kathmandu, one important point that got highlighted this time is that there is significant energy provided by the earthquake in the natural period range of 4 to 5 seconds or about 3 to 6 seconds if you want to go a little wider. And this meant that we are going to do a surgical bombing like we did in the 1985 Mexico City earthquake. That specific structures alone will get affected significantly. I also want to show that there is significant displacement at the base, and if the conditions are unfavorable, you will see large amplification in the response. So this 4 to 5 second pulse that we saw tells us that all long period structures would be affected. So the masonry structures loosely built are also long period structures. Computer programs will give you very stiff answers, but the reality is if they are loosely built, they will have very long periods, and we saw significant damage in them. We also saw significant damage to the only tall building then, and it really led us to thinking as to why that is happening, and it was obvious that very poorly built masonry structures, open ground story structures, all that will get into that window of 4 to 5 seconds or 3 to 6 seconds. And that is the pendulum problem that we will get into if you're looking at one very classic picture that everyone has been talking about and seeing is the loss of the masonry tower, a long period tower. Alongside, we also lost the boundary walls of the royal palace, which are also tall, massive and long period structures. So very clearly, one point that came out of this earthquake was that this long periods are something that we'll have to account for in our design of structures in the road ahead. One of the interesting things that happened was on the aftermath of the earthquake, Nepal needed to do post-earthquake occupancy decision making, and so they wanted a rapid visual screening. In a jiffy, we had created a form and shared that form with them, and but that led us to thinking about what we should do in our country, and so we then reconciled to the fact that we have enough work to do and classified our work into 4 levels of assessment and actionable points for us. And that led us to the first document of post-earthquake safety assessment of buildings that are standing there after the earthquake. Should we occupy it or not? And through the Bureau of Indian Standards CD39, we had created the Indian Standard IS 18289 as a rapid visual screening approach for post-earthquake occupancy decision making. The second one was that we organized all our earthquake safety assessment for pre-earthquake safety assessment. And we put them into 5 levels. And this 5-level telescopic method is brought into the standard, which is poised to get released in a month or 2. Likewise, we also have an important document which is on pipelines, because pipelines are also long period structures because they are sitting on saddles and they are free to oscillate back and forth. And they will also cross faults, and which means the large displacements that are there at the faults will have to be accommodated in their design. And so the Bureau of Indian Standards has now created another advanced draft, which is likely to be released in a couple of months on long distance pipelines. So in the last 10 years, what did we do? We had enough pointers we collected from the 2015 Nepal earthquake. We came and created those basic standards that came as an outcome. But let's summarize and see what we did. First item was that towards creating a earthquake risk reduction, and in the subject of mitigation, we said we will take serious cognizance of the near fault effects in the Indian standards. And so in the hazard design and retrofit codes, we had significantly reflected this pain that we went through in 2015 and the losses of life, because should another segment of the Himalayas break, we will have a similar environment of unreinforced masonry coming down. And so we said, let us now address this formally. And so in the form of near fault ground motions, we have now included this as a first step. In the road ahead, we might even give a spectrum for design of structures. The second one was in the design itself. We had seen that the long periods are a worry for us, so we would want only stiff structural systems. And so on the list of admissible structural systems, that was included. And of course, on the third side, we had created the whole series of standards for the 5-level telescopic arrangement for assessment of structures. So I would give, a complete, respect to Bureau of Indian Standards for initiating this effort to bring in the lessons from the Nepal earthquake. Second item is earthquake engineering education at the master's level. NDMA had created the teaching resource material, but training of teachers and augmenting the curriculum is still yet to be addressed. Third is licensing of structural and geotechnical engineers. The Indian Association of Structural Engineers has conducted mock exams and is trying to learn the ropes to how to do this in the road ahead. But legalizing licensing and implementing it are another set of activities that are yet to be taken up. So that was about one of the three agendas has been addressed on that. Again, structural safety at the municipal level, revising bylaws. Bureau of Indian Standards worked very hard and created the model revised bylaws for all the states, and they gave it to them. Also went and spoke to the engineers in the municipal level and sensitized them on the need to urgently implement the same. But empowering engineers and implementing the peer review at the state and UT levels is yet to be undertaken in a big way. And the fifth item is retrofit of structures. CBRI and IIT Kanpur came up with this twin lintel band system. And I'm praying that in the road ahead, the pilots that CBRI has initiated in the states, northwestern states, will really help in demonstrating that this is doable and it is quick and economical. I'm hoping that the states will take this seriously and implement it in a big way in the road ahead. So in summary, what we have seen is that we are halfway down the road ahead towards building systems and processes for mitigation. We have a long walk, but the easy part is done. The difficult part is, right at the field level. I pray that we will address that soon. So in closure, I'll simply believe that earthquake safety is only at the field level. In the books alone will not help. So, but for the field level to happen, the books and all the backdrop work has to be done, which is capacity building, R&D, risk communication, techno-legal regime, and earthquake safety policy are essential to strengthen state governments and UT administrations to take effective action at the field level. And this ecosystem is something that we have to strive to add to. From our side, each one of us working in different domains should actually do our little bit so that we are not shown a finger at saying that what have you done in the road that is behind us. So I'll stop here by saying that we need to do continued hard work because earthquake safety is not a one person's agenda. It is a national agenda, but it's a collective national agenda, which means all our efforts have to harmonically flow one to the other so that we can effectively show that in the next earthquake we have lesser losses of life and property. I'll stop here by thanking CBRI, especially Professor Pradeep Kumar, Director, and Ajay Chaurasia, Senior Principal Scientist, to have brought me here. And also my special regards to the two colleagues from BIS who were actually the rock solid members in trying to generate the revision of the Indian standards related to earthquake safety in the harmonization as well as creation of new documents. Arun Kumarji as well as Jitendra Kumar, they have been the backbone for us to be able to say that we have managed to walk forward in that direction. Ladies and gentlemen, thank you for your time and attention.
Thank you so much, sir, for your wonderful and crisp presentation as always. To summarize what you have given today is a country's progress. It is very difficult to measure year after year, but a decade is a very important time gap or time period in which we can properly measure. So in these last 10 years, because of the Nepal earthquake, what we have learned. So one is creation of new knowledge, and second is standardization of the same and putting the same into practice. So what you have mentioned in your talk is one is post-earthquake damage assessment standard, that is 18289. So which is now already released 1 year back, so in 23, a little over that. And then second is levels of standardization of earthquake safety assessment. That is levels of assessment, that is level 1 to level 5. And that standard is also going to get released soon. That's what you mentioned. And another standard for long distance pipeline. And another new knowledge, that is how to design and understand the behavior of the buildings in the near fault region and teaching materials. And also another pertinent issue which is bothering all of us, that is licensing of professional civil and structural engineers and demonstration of retrofitting technologies. So this is in short summary of what you have presented, and definitely all these points have immense value to all of us to understand, assimilate, and put that into practice. Now, having said this, we'll now move to our next panelist, who is Dr. Ajay Chaurasia, who has almost a decade of experience in working in the rebuilding of Nepal, especially in two sectors. He, along with his teams, now he will bring all that experience. Now, Dr. Chaurasia, here is your question. What innovations or the best practices in design have been adopted in the rebuilding of houses and public infrastructure in Nepal? Yeah, just to mention, there are over 250 registrations for online participants. So I warmly welcome all the online participants and hope that you are able to listen to all the deliberations and views of panelists. Yeah.
Yeah, thank you, Mr. Pratik, for uh, so basically, I would like to mention that the 2015 earthquake was not a simple earthquake for us. It was a turning point, in fact, for the fraternity of structural engineering. It has changed. We have not simply constructed or built the building or infrastructure in Nepal or in India. Rather, we have brought new scientific flip into thinking process, particularly from resiliency point of view, and not only the constructing the buildings from earthquake resistant point of view, but also from multi-hazard resistant resistance point of view. So what my experience during last couple of years in Nepal, which basically when you are talking about innovations, so our recovery efforts introduced basically the blend of innovations, local wisdom, and engineering best practices. When I'm talking to you when about the multi-hazard resistance, so whatever the infrastructure what we built, that was not only the earthquake resistance, but it was getting to the resiliency in terms of heavy rainfall, landslide, and comfort is also important, that we should provide comfort to the occupants also. So that is the innovations what we have incorporated in our designs. As I have mentioned in the beginning that the task was very enormous. Lot of buildings need to be constructed in the Nepal for the sectors. So for that purpose, for few buildings we have given a specific design, but for most of the buildings we have adopted the model of type design. In the type designs, whatever designs we have done, so in that the community participation was given a more impetus, and thereafter the scalability, modular, and adaptation to various site conditions was the focus point in the design process. Next important aspect is about, because whenever you talk about any construction activity of any building, so people are designing in one vertical and constructing in another vertical. There is a no sync between the two. So we have ensured that we should carry out the non-linear dynamic analysis, even if the building is very small, so that it should be robust. But how to make this particular building a robust, it should be done properly during the implementation. And for that purpose, stringent norms, particularly focal point on materials, processes in terms of ductile detailing was has been given very much importance. So functionality is also very much gone into the design process, which has led to the functional efficiency, space efficiency. Next important thing is when you are talking about housing. So there are a lot of houses which were damaged. As Murthy sir mentioned about the MS twin lintel band, So we have propagated the idea of MS build lintel band for retrofitting the existing building. In contrast, for the new construction, we have propagated the use of confined masonry, which makes use of locally available construction materials and skill, and that has been adopted from the socially acceptable point of view by the people of Nepal. And last but not the least, whatever the construction we did, so that were monitored very strictly, digitally and physically also. So for in terms of digitally, we have developed the dedicated mobile app. The results were updated on the website of CBRI and for the reconstruction. And everything was not only monitored, but it was ensured that proper compliance to the observations made by the engineers of CBRI has been implemented. As a result, I really like to mention that after the construction, the timely construction was there. Very thanks, and the people are people of government of Nepal and government of India are thanks to CBRI for our endeavor. But important thing is that whatever the construction we did that were really robust, that has been demonstrated during the past few moderate events which has occurred in the Nepal. Even not a single minor crack we noticed in the post earthquake the built up environment what CBRI has done. So this is in short. I want to mention about the innovations and related aspects.
Thank you, Dr. Chaurasia. So you have touched upon the collective experience of you and your team in doing this post-earthquake rebuilding of especially housing and health infrastructure and schools. So basically, the points what you have mentioned are come under these categories of safety, functionality, sustainability, and economy. And together with that, the interaction with the local people and also other experiences you have added. So thank you so much. Now we'll move to Professor Sri Nagesh, Professor of Practice at IIT Madras. So, sir, your question, that is, how has our understanding of fault lines and seismic risk in Nepal changed since 2015?
There are two aspects which are extremely important for us to understand the earthquake risk and the fault lines. First is the low frequency high ground motions which were recorded. That means the accelerations were about less than 200 centimeters per second square, but the velocities were higher, which caused the damage. And the dissimilarity from the previous earthquakes, which is a unique fault in which the geological conditions led to a different type of ground shaking. That is number two. Number three, what is very important is all the earthquake risk studies or earthquake hazard assessment which was carried out is the ground response analysis studies of the Kathmandu Valley should have been incorporated. Though they know that there are the lacustrine sediments which are present within the Kathmandu Valley, but the response analysis very clearly shows due to this earthquake that, as Professor Murthy has shown, that the long period dominant frequencies have been very clearly seen. So the two aspects of this particular earthquake, which I personally feel is the low frequency and the high ground motions leading to damages, and the dissimilarity from previous earthquakes because this was triggered by a unique fault system and the geological conditions leading to a different type of blockchain. That's my answer to the first question.
Yep. Thank you, sir. So for giving the details about ground response analysis and basically the geology in a crisp manner. Now we'll move over to the next panelist, which is Professor Yogendra Singh ji, who was also part of the reconnaissance team when we visited. Professor Vai Singh, so here is your question. What did the 2015 earthquake teach you about balancing cultural heritage and structural safety in design projects.
Thank you, Professor Pradeep Kumar. Thank you, Dr. Chaurasia, for inviting me to this discussion. So, in 2015 Nepal earthquake, we and all the fraternity had experience regarding performance of different types of structures, ranging from old historical heritage structures to the most advanced multi-story flat construction. And what we saw that there was a mixed type of performance which was seen from the heritage structures. For example, timber structures performed quite well, and some temples performed those sustained that earthquake. On the other hand, some other heritage structures, which were mostly masonry structures with thick masonry walls, those could not survive those earthquakes. So what we understand is that uh, our heritage construction, we have to look individually. So there are some construction forms which are quite safe for earthquake, but not all heritage structures are safe enough. And to safeguard those structures against future earthquakes, we have to do some retrofitting. And that is required in Nepal, that is required in India and any part of the world. And then Nepal earthquake also tested the performance of our modern construction. So there is a case of a famous case of Park Horizon apartment, that multi-story building that performed quite well from the point of view of uh, intended performance in the codes, because there was no structural damage. The structural damage was mostly limited to masonry infills and non-structural components. And it was seen that although the building has performed quite well from the code point of view, but economically and from the point of view of accommodation, it was a complete loss. And the retrofitting could have the discussion there when we had from the people. So retrofitting of that type of building will require something like 80% of the original cost. So it is a huge economic loss. So we need to think in that direction. And I have learned that in 2020, Nepal has revised their code, and they have included performance-based design to some extent in their code. So we also need to think in that direction, that we have to look not only from the collapse prevention strategy to design our structures, we have to think beyond that. A better performance we have to look for. Thank you.
Thank you, Professor Weissing. So you have touched upon many important points. Let me summarize. First is you mentioned that the earthquake, because of earthquake, there was mixed performance, and many timber structures performed well. That is one important point. And the other point you said, which is to be noted, is each heritage structure has to be looked at differently or individually. So many heritage structures performed well, but some heritage structures needed uh, retrofitting. And other thing is you commented on the performance of the modern structure. So I still remember that there was a 17-story apartment structure whose natural period was over 2 seconds, as it is already mentioned in Dr. Ajay Chaurasia's presentation, also Murthy sir's presentation, and touched upon by Srinagesh ji also. This earthquake had a long period waves, so that's why the structure got damaged. And when he also mentioned that retrofitting activity can be taken up. However, the cost of retrofitting was around 80%. So recently, NDMA has released a guideline mentioning that if cost of retrofitting is more than 50%, then that structure has to be reconstructed, unless it is a heritage structure and important structure to be preserved. So many important points, and just it triggered when Professor Weissing was saying these long period waves have damaged many boundary walls in Nepal, and also the tower Darhara Square also got damaged because of long period waves. Now we'll move to our next panelist, Sri Anup Karan, representing World Bank. Uh, so your question is like, how did community resilience and traditional knowledge contribute to survival and recovery efforts during and after the disaster?
Thank you. Thanks for this question. And it is always good to have a question in advance. So, I was just trying to wrap around, in terms of what all I should bring as a pointers here. So my experience of going to Nepal actually began with the Gujarat earthquake happened. So the Gujarat earthquake, when it struck on the 26th of January 2001, I was an engineering student, quite hit hard by my mind. I was in my final year of engineering, working on performance-based composite materials. And, on that day, I realized that, it is such a thin line between what you do as research and what actually happens in practice. I actually tried jumping onto the building, and I need to tell this every time because that is where the behaviors actually come in. That's where the community knowledge and all things are. My first reaction to this event was in Gujarat when the earthquake hit, somewhere in the month of April. There was a consortium of agencies who participated, and a lot of people actually came from Nepal to basically say that this is what we are doing in our country. This is how we started, preparing for earthquakes. And I was quite very sure, how this happened. So I picked up my bag. I finished my education, engineering. I picked up my bag and I actually went there. And I stayed there in Bhaktapur. I stayed in a lot of places around Bhaktapur. Traveled across to a large number of places where people normally venture and try to understand in terms of how these community practices are actually being done on the ground. And I was quite intrigued with the fact that a large number of people then in 2001, somewhere in the month of September, they were actually doing safe construction practices in far-flung areas of the hillside. Now, there were a lot of interesting things which actually made this happen. So there was a general understanding of the community's understanding of earthquake. So there's some toddlers and some elephant rumbling around. And this knowledge exists in the community. When there is a bit of mix and match with those animals, something happens and the earthquake, wobbles and the buildings collapse. Now, this is very much rooted in the traditions that earthquakes are very frequent. This is nothing new for them, but it's actually experimental. So how the scientists and the engineers went around, communicating this, there was a bunch of engineers, barefoot engineers, architects, a whole lot of people who were actually working on a program called Kathmandu Valley Earthquake Risk Management. This started somewhere around 96, 97, and they created something called earthquake scenario. And that earthquake scenario, when the day when the earthquake happened, it did remind me that those earthquake scenarios, which were prepared way back, in the 1999, 2000, and they created a lot of storylines around it. When an earthquake happens of this nature, this is what will happen. This is how the buildings are going to collapse. This is how, people have to come together. They also started celebrating Earthquake Safety Day on 16th of January every year. They do this massive effort across the country, it's a countrywide exercise to raise earthquake awareness. Now, just to come to this question that Dr. Raman Chandra asked me, it is not 15 years of efforts that would have translated into a lot of lives not being lost. I don't know how that is being captured. It is not being lost. A lot of buildings did not collapse for the simple reason that the mandatory rules of thumb, which we have in our documents as codes, etc., had to be taken to the people. And there is enough documentation of how the mandatory rules of thumb are expressed by demonstration of good housing practices in the communities by doing, all kind of jingles, by taking it through community radio, by actually organizing, small little tempo, which carries all this great IEC materials, goes across to large number of, places, telling people how to build houses, how to build schools, how to make earthquake safe construction practices, how to have disaster management plans in office buildings, how to have your hospitals functional. And what I understand, from my little experience after this event was when I reached out to a lot of my colleagues and institutions who were part of this drive for 15, 20 years, they did come back with a lot of understanding of how communities participate and how communities were able to save their lives. So maybe these numbers, what we see today, I mean, any single life lost is a big loss for our country as well as for their family. But what I believe is that all that efforts that they did way back in 1996 onwards to create that kind of awareness did pay off significantly on that level. I just want to basically say that on the side of the reconstruction efforts, the unique approach that the government took there, I mean, despite all this, they did lose a large number of housing stock. I think close to about 850,000, 900,000 had been rebuilt. From the World Bank side, there was a program that was facilitated. We organized a program, a World Bank finance program of $700 million, which actually looked into reconstruction of houses. Close to about 320,000 houses were actually built through that effort with all the partners in the country of Nepal, including the local communities. But the real effort was actually a community-led, owner-driven construction process. It was also communities in terms of your masons, your engineers, and all been trained. That whole community-led action by involving the local government institutions, also bringing in the institutions from the national level, which included the NRA, the National Disaster Risk Reduction Management Agency. A whole host of institutions came together to make this happen. The owner-driven construction, I think, is a unique effort. I think this is something that is being tested. It was tested earlier in Gujarat. You bring in the communities, you ask the communities to be part of the process so that you understand latest engineering and construction practices, because not all that traditional buildings, getting built because, you have issues of local resources. So obviously building construction typologies are changing significantly. And in the kind of owner-driven construction program, it's very hard to go back and, get those kind of right resources like wood, etc. becomes very complicated to bring that back into the construction practice. So in the ODCH, it was typically owner-driven construction, but ensuring that, all the codal provisions are accommodated, it's actually built in a significant way. There was also a mechanism to ensure that you have the right grievance redressal mechanisms put in place. The community ownership, the kind of, local leadership and coordination was very much required to make all this happen.
Uh, Thank you, Mr. Anup. You have touched upon very, very important points. So out of that, I got stuck at one, that is community participation. So, and also you mentioned about this Kathmandu Valley Community Resilience Mitigation Program and earthquake safety day, which people practice. And generally, if you look at, so wherever earthquake safety day is celebrated or practiced anywhere in the world, during the earthquake, it was mentioned recently by Professor Harsh Gupta. He has clearly given the numbers that their losses were very less because the practice or resilience is already inbuilt. So we need more such uh, states and cities to embrace community resilience. Now, coming to very special guest we have today, Shri Narayan Singh ji, who is first secretary, Embassy of India at Kathmandu. Sir, I warmly welcome on behalf of CSIR CBRI to this panel discussion that named as Ruins to Resilience. Sir, I would like you to touch upon the point, that is what are the most critical challenges Nepal has faced in the immediate aftermath of 2015 earthquakes? Two earthquakes.
Uh, Thank you, Dr. Pradeep. It's a pleasure to be part of this panel discussion. So it's important that we reflect on what we have been doing and the best practices we share with each other. So in terms of challenges faced by Nepal after this earthquake, I would like to mention a few things that as you people are aware that in this Himalayan range, this is a very climatically very disaster prone area. Now next week we are having Sagarmatha conclave, where they will be focusing on this fragility and what kind of climate change related measure they should be taking. So earthquake has been a recurring phenomena here, but of course 2015 has been particularly very disastrous, the kind of intensity and kind of damage. And India being a quick responder, we were able to put at place our resources. I hope you can hear me. Hello.
Yes, yes, you are audible.
Yeah, you can hear me.
Yes.
So, yes, sir, you are audible.
Yeah.
So the challenges, of course, the utility part, like restoring the water pipelines, sanitation, and the private housing, of course, is an important part where people are directly hit. So, those are the thing where the government's efforts to put together the international donors and their own resources, that was, I think, their limitation. They were not able to put it together. Then UN agencies and other international organizations who have experience in this, they, and of course the role of CBRI at some point in putting the efforts. So, but as a country, they are not prepared. Their systems are not in place to handle these situations, despite these things happening time and again. So I think that is what is the most challenging part, which they have to learn to be ready for these recurring disasters. So the challenge is, I think, the governance, on the part of governance, having a system like NDRMA, like our NDMA, National Disaster Management Authority. They have NDRRMA. So that is also a very transitional. At that time, they had one NRA, Reconstruction Authority they built, which was coordinating all the donor agencies' efforts. But that also got dismantled. Then Jajarkot earthquake happened in 2023. At that time also, they started getting donations, but till date they are not able to put in place the plan how to use it. So I think mobilizing, not only mobilizing, channelizing all the resources, all the donors and their own in a proper way is the major issue I think this country has. This is what I believe. Yeah, I mean, this is a very common kind of version I'm giving, not of course at the infrastructure level, which you may be expecting that I tell something on that part, but this is a general overview I could give. Yeah, thank you.
Yep. Thank you, sir, for joining the panel discussion and giving very important points and also insider views of what has happened immediately after the Nepal earthquake. So to touch upon the important points, what you mentioned, one is the main challenge was how to retrofit or bring back the lifeline services. Most importantly, water supply, electricity, and other services. And also running of this temporary shelter camps and coordination between international organizations and a massive Nepal rebuilding projects and mobilization of resources. So thank you so much, sir, for giving important information on the immediate aftermath of Nepal earthquake. Now, I'll move to Professor Rupen Goswami. So, Rupen, your question is a little longer. So, what specific structural weaknesses were identified in public infrastructure, such as schools, hospitals, and government buildings during 2015 Nepal earthquake?
Okay. Good morning, everyone. Thanks, Professor Pradeep, for that. But before I get into specific weaknesses, I just would like to, highlight a couple of things. Immediately following the earthquake and all, there were a lot of efforts in time to understand what is the extent of damage and so on and so forth. So some studies were done. And one interesting thing that came out, which is very unique to Nepal and some other major events also, it has happened in the past, is that if you look at buildings damaged, I'm clubbing for the time being, your schools and other, hospitals and other things. If you look at the kind of buildings that were damaged, it was estimated that about 5 lakh buildings were completely damaged or destroyed. And about 2.5 lakh buildings were partially damaged. Typically, what happens is you have fewer number of completely damaged structures and more number of partially damaged structures. Here it was completely upside down. that ratio. So that just shows the extent of damage and devastation that happened during the 2015 Nepal earthquakes. And it was actually, there were, if we count the number of aftershocks, there were many earthquakes actually. The two main, of course, you have mentioned. But so why did this happen? If we really try to look into that, what was found was very interesting, that all these buildings, be it normal residential buildings, health centers buildings, and other buildings, uh, could be classified into three broad categories. One is the classical, very low strength, practically unreinforced masonry houses, masonry buildings. These were the, I think about 95% of the, the whole stock. And these buildings did not have a chance, did not have any chance to survive. Then, of course, the relatively newer constructions were the same masonry construction, but in cement mortar. The previous, kind of structures would be, starting from in the rural areas, in the upper elevations, stone masonry, random rubble masonry, to unburnt clay brick masonry in mud mortar, all those kind of things. Then later on, newer structures were masonry structures, but in cement mortar. These were relatively fewer in number. And then, of course, the final type of structure is the modern, so-called modern reinforced concrete structures. So if we look at the extent of damage that happened, it was primarily the masonry structures which were damaged. But having said that, I will also remind and say that I think, if I remember correctly, the estimate was that around 6,000 to 7,000 reinforced concrete buildings collapsed. I mean, destroyed or uh, irreparable kind of situation, and close to around, basically around 20, 25,000 reinforced concrete buildings were damaged or destroyed kind of thing. So it tells us that even the so-called modern constructions uh, had some weaknesses, and that is where I'll come to your specific question of what are the weaknesses. So obviously, if I look at the masonry structures, low strength, no. So basically, I'll put it this way, that one was the material strength deficiency, and the most important part was the integrity, lack of integrity, right? A lot of these walls, the gables collapsed. Out of plane collapse of masonry walls was common, very common, right? Uh, Separation of at the corners was observed uh, almost everywhere. And then when none of these happened, then obviously we had the classic masonry failure in terms of sliding, shearing, cracking, and so on and so forth. So all the classic damage features were observed there. When it comes to the reinforced concrete, of course, this open ground story problem was prevalent there also. In addition to that, the other very classic problems that we have seen is uh, shear failure of columns and axial crushing of columns. Now, this is a classic design or lack of design and detail kind of feature, right? That also we have seen in some cases. We have observed even beam column joint failure, and of course infill wall failure, out of plane failure of infills, and so on and so forth. So basically, for all these modern constructions, again, the lack of stiffness, lack of strength, lack of ductility are the main weaknesses, so to speak. And it's so that there was, it was the lesson was that these are the known things, that these deficiencies would cause harm to buildings and people living in them. But then the same problems existed. And that is where I think we also used to have the same thing in previous earthquakes. We have faced the same problem, same deficiencies in our structures. And that is where I strongly agree with what Professor Murthy highlighted, that in the last decade, there has been, tremendous push, at least here in India, where we are revising our Indian standards to bring in at least these basic features before we get into very high sophisticated, analysis design procedures. These basic things have to be done. These are non-negotiable items. And if we put in all these and then get them implemented, of course, we have done the first step, but then implementation, education, these are important things. One last point. So, regarding the school, and we have talked about, you in the opening, you have mentioned about deaths and injuries. Very, very important thing to note here is that about 7,000 school buildings were damaged or destroyed. And this happened on a Saturday around 12 noon, 11 something, 11:40 something, right? It could have been a much worse situation with the younger generation getting injured or, getting killed if the earthquake had happened at some other point in time. We have seen these kind of situations where a whole generation gets, into trouble because of failure of school buildings. We have had hospitals failure, collapsing, mm, health center post, buildings and houses. So these are all, the classical masonry structures which underwent severe damage, partial collapse, full collapse. So these were the main points that I would recall from that visit to Nepal.
Thank you. Thank you, Professor Rupen. So you have touched upon very important points, especially on the infrastructure, particularly referring to buildings in housing sector, schools, as well as hospitals. So one point which we have brought is usually uh, after the earthquakes, we see some buildings collapse of some buildings and large number of buildings partially or severely damaged. But this, as you mentioned, that this earthquake, so 5 lakh buildings got collapsed and 2.5 lakh buildings partially damaged, so completely reversed. And the buildings which were collapsed, you categorized into three. One is low strength, medium, and like sufficient strength kind of buildings. So out of which 85% of buildings are of low strength got damaged. And usual features of buildings which collapsed have a lot of issues like sliding, sharing, infill wall problem, and beam column joint problem, out of plane problem. And also you have touched upon the standardization after the post earthquake. So now, thank you, Rupen. Now we'll move
Thank you.
on the point of standardization. So I request Shri Arun Kumar of Bureau of Indian Standards. So, Arunji, here is your question. How has Nepal revised its building codes and construction standards after 2015 earthquake to enhance resilience? And also, I request you to touch upon what India has done during the same period. Arunji, over to you.
You have to unmute. Not yet.
Arunji, you have to unmute yourself. Maybe some audio sync issue. Yeah, okay. So I'll get back to you. Now we'll come to our next panelist, Dr. D.P. Kanungo from CSIR-CBRI. Kanungoji, here is your question. What technological tools, so especially early warning, or drones, or GIS. So proved most valuable during and aftermath of the earthquakes, and how can they be better utilized going forward?
Yeah. Good morning to all the dignitaries, the panelists, and all my colleagues and online participants for this session. Actually, I'll talk with reference to 2015 Nepal earthquake, even way back in 1990s, Uttarkasi and Chamoli earthquake in India and Himalaya. So that technological advances is enormous. Now we have seen a lot of advancements in technologies, but the utilization of that is very much important. Like if I take the example of drones or airborne lidar, nowadays we are talking of these sort of advanced technologies, and there we know it's very useful for our post-disaster damage assessment. Even it can go up to centimeter scale resolution and with millimeter accuracy. But quite often it's too costly, and then the fund availability restricts us to use all these advanced equipment. Another aspect of this is we are still in the hazard zonation mapping stage. Still, we have already revised the earthquake zonation mapping, but still I see the research to be published on zonation mapping. But if we look forward for the next step, which is vulnerability and risk assessment of the built infrastructure we have around, so that it can help us in taking a stock of the buildings and the quality of the buildings and strengthening it, or even we are going for a new infrastructure development, then we can plan it better. The next thing I will talk, a tool, wonderful tool is GIS, Geographic Information System. It talks about, but it is useful only in case of quality and quantity of data on a spatial scale. So the quality has to be maintained for any type of data generation and the quantity of data. So it addresses a whole lot of problem. We can talk about multi-hazard mapping, multi-hazard zonation, multi-hazard risk assessment. If the data, but in Indian scenario, always we heard of data scarcity, the sharing of data is an issue. So we should focus on maybe a data center on whatever data related to earthquake, whether it is hazard or damage, any sort of strengthening measures can be collected in a data center, and it can be have an open access to all the researchers and academicians who can come up better to have a resilient society. The next is earthquake early warning system. We talk a lot about earthquake early warning system, but being a disaster management person, I call it post-earthquake early warning system. Once earthquake occurs, if it is a near source, we'll have a less lead time, and if it is far source, then we'll have a somewhat more lead time in seconds. So it's basically we are talking about post-earthquake early warning system. But we should look forward. Now there are a lot of GNS, that is global navigation satellite system based or DGPS based systems we have deployed across the Indian Himalayas and different parts of the world, of the globe, that we measure the stress or strain accumulation, we work on the crustal deformation. So can we think of having a threshold for the stress strain accumulation, so that beyond this threshold we can expect an earthquake of this magnitude? Like we do in case of a landslide disaster, we are now talking about rainfall threshold. So beyond this rainfall threshold, we can expect certain type of landslides. So can we develop a stress strain based threshold, so that we can talk about actually the earthquake early warning system? Another tool, I am still struggling since 1990s in Uttarkasi. I have seen Chamoli, we have seen there are a lot of bodies underneath the rubble or demolished infrastructure or debris. So how to identify where the bodies lie? Still, we go for digging it and digging it for many days and taking out the dead bodies, or we are taking the help of our trained dogs, army dogs, to identify whether there is a body or not. If the person is still alive, then it's easier. The sensing system is available to identify the body beneath it. But once the person is dead, yes, we need to develop such technology so that, or scanning system, so that we can scan on the surface and find out where are the bodies lying. These are my
Uh, Thank you, Dr. Kanumbu. So you have touched upon very important technical advances and also mentioned few technologies, especially that GIS. You mentioned that quality of data is important and also the quantity of data is also important because whatever we get from that only we can give inferences. And other important point you have mentioned, that is about the data sharing between the people who are working on the same problem. So I think for this problem we need a different kind of solution of human behavior. And also another important point which touched me is that early warning system, not early warning system for earthquake, but early warning system first for post earthquake activities. And already now the hazard map is prepared and it is going to come soon. What we need to work on is vulnerability as well as the risk aspect. So these are very important points you have touched upon. Thank you. Now we'll move to Arun. Uh, Arunji, you are ready?
Yes, I hope I'm audible now.
Yeah. So do you want me to repeat the question?
No, no, sir. Thank you. Thank you.
Yeah. Okay. Please go ahead.
Apologies for that small glitch in the technology. Um, as regards the question with respect to how Nepal got its standards upright, and the second question was how India has shaped up its standards with respect to the topic of today's discussion on earthquake. Particularly, we can see that the national standards body of Nepal had developed NS 500. But beyond that, with respect to buildings, the Ministry of Urban Department in the government of Nepal, it had developed four standards relating to earthquake, of which the first one is quite important, which is on the seismic design of buildings. And the second one talks about masonry, load-bearing masonry buildings. Third one talks about low-strength masonry buildings. And finally, it also, the fourth code talks about the earthen buildings. Above all, similar to the National Building Code of India, the Ministry of Urban Development Department in Nepal had also prepared the National Building Code with respect to architectural services. Coming to the first standard on similar to 1893 of BIS, the NBC, they call it Nepal National Building Code 105-2020. That was the year they had revised after the 2015. And in that particular standard, as some of our earlier speakers mentioned, apart from adding some inputs on the performance-based design, they have categorized the seismic, they have redefined the seismic hazard values. And they have brought in both dynamic characteristics values for the calculation of various parameters, which are essential for the design of buildings. And the code of Nepal, that is NBC 105 of Nepal, it permitted both the equivalent static method as well as the linear dynamic analysis method through modal response vector method, as well as to elastic time history analysis. And apart from that, they have also introduced the non-linear static and dynamic analysis method. And finally, more importantly, they had touched upon the effects on components or the non-structural elements or the HVAC related equipments which we typically see on the rooftop or as appendages to buildings. For them also specific values were given in this particular Nepal standards. And more importantly, for buildings like hospitals and educational buildings, apart from, say, your disaster management centers. In this edition of the Nepal Code, they have enhanced the values or the limits for safety, so that these centers are up and functioning even during a time of disaster or immediately after the disaster also. This is a similar approach which India has been following up. This is very much evident from the value of importance factor which they have given as 1.5 to such buildings, and 1.0 for regular buildings, and 1.25 for other buildings. So 3 values of importance factor they are given, and also the seismic zoning factor has been, there are 4 seismic zones and there were 4 given factors: 0.25, 0.3, 0.3, 0.4. And more important after the Nepal earthquake is on ductile detailing. The parameters for beam column junctions, also shear walls, if it is a RCC building, that has been given. If it is a steel building, then what are the requirements for such structural steel elements to enhance the ductility? Those are also given in this standard. And importantly, the other standard, which is called as Nepal NBC 202, it talks about the unreinforced masonry. They have now clarified only 2 stories of brick masonry and 1 attic floor is permitted, nothing beyond it. Even our own NBC is permitting 1 more story above. Anyway, because Nepal is on the Himalayas line, they have only permitted up to 2 stories, even if it is brick masonry or a stone rubble masonry also. And they have also talked about bands, particularly at plinth level, sill level, lintel level, as well as at floor and roof level also, and more importantly, all double bands which can be just below the windows or also just above the window level openings also. And also vertical reinforcement in walls as well as horizontal reinforcement in masonry walls have been emphasized, so that if somebody is going to construct such buildings, those buildings can also perform. It is not only that only RCC buildings will only perform, even properly engineered and designed and constructed by a proper engineer is going to perform. That is the essence of it. The third standard is talked about the low strength masonry, where only 2 stories again is permitted, wherein the limitation of floor to floor height is only 2 to 3 meters. And also the span is also given to that extent. And even the area of such building is also given. Nepal code is quite simple. If somebody goes through that, and NBC 203, which has come in the year 2015, same year, one can see that it is quite easy to understand and follow. This is all with respect, I would say quickly, with respect to the Nepal standards. Coming to our Indian standard for the second part of the question, Professor Ramachandra mentioned, we all have been seeing 1893 Part 1 2016, which got revised immediately thereafter the 25th of April earthquake. Along with that, IS 13920 on ductile detailing also came up. Both these formed a place in the National Building Code of India also. And that was a critical step because in India, it is a building bylaws which is governing the construction in various states and UTs. And all the bylaws have been processed into National Building Code. So the inclusion of 1893 in Part 6, Section 1 and 13920 in Part 6, Section 5 of NBC in a way legalized the importance of following the Indian standards. Apart from these 2 standards, the next major thing also came up was on the tall building code. Although tall building code is like a special structure, but given the urbanization sector in the urbanization scenario in the country, the 16700, which came up in 2017, also which was revised once again in 2023, gives more thrust with respect to not only earthquake safety provisions, but also even beyond, because these are the buildings which are going to house many thousands of people, considering the height range of 50 meters all the way up to 250 meters. Also talked about code exceeding buildings. And the confined masonry standard 17848 also came up in the BIS parlance after the series of developments. And also one more standard came in was on ductile design and detailing for steel buildings, IS 18168, which talks about variety of braces, steel braces, etc., which can be provided for steel buildings, which can be either used in regular buildings or for industrial buildings also. One other important, which both Professor CBR Murthy Saab as well as Professor Ramachandra talked about, was on the assessment of buildings, which has a color-coded system, which my colleague I believe will be touching upon. And also another aspect was on the base isolated buildings, 1893 Part 6. that was also developed through the Earthquake Engineering Section Committee CD39 of BIS. So it is not only CED which is making standard. The Service Sector Department of BIS also developed two important standards, of which one was on structural design consultancy, the essence of which was used in the Standardized Development and Building Regulations SDBR, which is a special publication 73 of BIS, which has been used, which has been handed over to all states and UTs, and it talks about the requirements of proof consultancy for special buildings. And finally, the Service Sector Department has very recently come out with another standard for geotechnical services, how that particular services have to be verified, used, and can be cross-checked also. And more importantly, numerous other Indian standards of BAS have been taken up for revision based on the probabilistic seismic hazard analysis based map of India. Not only 1893 part 1, also the part 1 has been bifurcated. Some of you who are following the BIS wide circulation drafts or the BIS website, etc., must be aware. Also 13920 ductile detailing has been bifurcated, and also the pipeline standards were talked about earlier. Also, the part 4 on industrial structures and stack-like structure standard has come. And the dam structures, one of the part has also very recently out for committing purposes, and also the numerous other standards will be coming out. I'll stop here. I think both the countries have ensured that all the standards and also the other legal requirements in terms of SDBR or the Standardized Development Building Regulations are now in tandem talking to each other. We only want the professionals to utilize those standards and technical documents.
Yep. Thank you, Arunji. So you have given a full picture of what has happened in last 10 years, especially in Nepal after 2015 earthquake, as well as in India also, particularly in the standardization. So, to summarize what you have mentioned is Nepal has developed 4 earthquake-related building standards. That is one. So in that, one important thing is NBC, that is Nepal National Building Code, which was released in 2020. So they have adopted performance-based design, and also the safety of non-structural elements in buildings, especially in hospital buildings, and the importance factors what they have adopted for the critical buildings, important buildings, and regular buildings. And also revision in their seismic zonation map, and restriction of masonry buildings to 2 stories or 2+1, implementing the double seismic bands. And vis-a-vis, you have mentioned what are the developments which are taken place in standardization in India. So it's a very happy news that the new codes or the codes which are getting revised are most updated, and following that, definitely we will be very safe, especially 1893, which is the primary code for criteria of earthquake resistant design of buildings, and 13920, 13935, and 17848, and also code based on steel braces, and many more things you have touched upon, and also tall building code of India, which got revised in 2023. So thank you, Arunji. So I'll get back to you with more and again pointed questions. So now over to Dr. Hari Kumar, who is from GeoHazards International and also visited Nepal after the earthquakes. Now, Dr. Hari, here is your question. What gaps in disaster preparedness and response in the health sector were exposed by 2015 earthquakes, and what measures have been implemented since then? Just wait for a minute. I have a request to all the online participants. So you can post your questions there, and because of the shortage of time, I will take only some selected questions. And if it is possible, you mention to whom you are pointing that question. So, okay, Dr. Hari, please.
Thank you. Thank you, Dr. Pradeep. It's really wonderful to be here in CBRI. One thing I must say, we're talking about gaps in Nepal and their response. I must really start by saying that Nepal started its resilience journey even before India, in the sense that Anup had mentioned that work had started in the 1997 itself, the scenario. And I'm happy that it was initiated through efforts of Geohazards International. Though I was not part of Geohazards at that point of time, but we had initiated the scenario. And this is the power of scenarios, because it is a tool which helps governments visualize what exactly can go wrong and what mitigating steps can be taken. So Nepal started working on hospitals and schools very early, somewhere around the 1990s, in the late 1999. The Earthquake Safety Day is a wonderful example of something which was started in 99, still goes on. And that is the importance of these events, marking these events. And in the health sector, I'll talk about the ruins first and then come to the resilience part. Uh, and in the 2015 earthquake, Nepal's health sector took a hit basically with damage to buildings. More than the damage to buildings, what had happened is that many of the hospitals did not function. And that was not because of damaged buildings only. Damaged buildings, of course, played a part, but it was the loss of electricity. It was a lack of power backup. It was a lack of, there was single source of water in many of the main hospitals, such as the Beer Hospital. The Beer Hospital is the biggest hospital in Nepal, and they had a single source of water supply, which was dependent on electricity. So when electricity failed, they didn't have backup. So many of these effects on the health sector happen because of a lack of functionality. So which is where I was very happy to hear from BIS that we are looking at non-structural aspects as well. Because it is, for a health sector, it is not just safe buildings which matter. For the hospital, it is not safe hospital we are talking about anymore. Safe hospital means your people who are inside the hospital will be safe. But in an earthquake, what we want is functional hospitals. And for a hospital to function, building safety is just one element. The important, your equipment have to remain functional. You know, you're talking about uh, earthquake injuries. That means broken bones, crush injuries. So your X-ray machine is not functioning. How are you going to treat? If your operation theater is not functioning, how are you going to treat? So that these are the things which actually happened in Nepal hospitals. Most of the hospitals evacuated fully because in many cases it is the false ceilings which are above all of us here also, which came down. You can imagine in an operation theater, if the false ceiling comes down, are you going to be able to operate on patients? That's not going to happen. So that is what happened in the health sector. And there were a lot of building damages, yes. In Gorkha itself, in the Gorkha District Hospital, I was part of a team from the Earthquake Engineering Research Institute, EERI, and I was looking at the health sector. Many of the buildings which were actually, when they were built, were perfectly symmetrical buildings. But doctors' needs increase. So there are many additions and alterations done on these hospitals. And they resulted in poor behavior of buildings. Buildings which should have behaved perfectly well if we had not actually added one room there, another room here, or one room above, without really considering all the building systems. So that was one of the factors which I really noticed across hospital buildings where many additions and alterations were done. Second was the failure of the power backup and water and utilities and lack of preparedness, which Anup had touched upon, that Nepal started its journey towards preparedness, towards resilience right in the 1990s. But the most focus was on schools. Dr. Ruben mentioned about the loss of school buildings. But we must also appreciate that over 300 or 400 buildings which were retrofitted by Nepal, none of them, not one of them was damaged in that earthquake. So they have done a lot of work in the school sector, but unfortunately not enough in the hospital sector till the 2015 earthquake. I myself did assessment of several hospitals in Nepal in 2013, looking at non-structural elements and working out whether they will be functional. And there was actually the WHO globally had released a tool in 2014, which was field tested in Nepal in 2014 November, and just a few months before the earthquake, and the results were, the assessment results were verified by the earthquake. So much so that the government of Nepal wanted us to go back and do a validation of the same test in the same two hospitals, Beer Hospital and another hospital. And things which we had noted, like the transformer of the main transformer of one of the hospitals was just kept on 2 poles. And we pointed out that if in any earthquake shaking, this is going to fall down. And even if power is restored in Kathmandu, rest of Kathmandu, you will not be able to access it because you don't have a transformer to access it. And that hospital was using generator power, running on generator power 32 days after the earthquake, just because this small 2 bolts would have done the trick. Non-structural elements we are not giving enough attention to, and that can actually make hospitals not work. And the 8,700, the death toll, which figure was shown in the first slide here, if the hospitals were functional, that may have been, yes, some lives would have been saved if the hospitals were actually functional. They did many things afterwards, after the earthquake, learning lessons. They were very swift to enhance preparedness in their hub hospitals. They were very swift to give supplies, emergency supplies to key hospitals. They took all the recommendations from the HSI, the Hospital Safety Index, which we had mentioned earlier, and they customized the tool. It's a global tool. It was customized for Nepal. It was customized for Nepal, and they have now carried out several layers of assessment of their hub hospitals and their district hospitals. They are progressing, and I think there is a lot of lessons which they have taken from the Nepal earthquakes of 2015, and they're on their way. I'm very, very glad to interact with the Ministry of Health in Nepal, because they are always progressing forward, especially after the earthquake. Thank you so much. I answered your question.
Yeah, Dr. Puneet was really crisp, as well as at the same time you have touched upon very important points, especially how Nepal has initiated its resilience activities and inputs from GHI, that is in 1997. You mentioned upon some tools which were used, and your elaborate explanation about health sector and what are the minor things which we usually take it casually may result in a major uh, inconvenience or major trouble in the aftermath of earthquake. And hospital building, the reason for hospital itself is whenever people are in need, it has to serve its purpose. So after the earthquake, definitely uh, hospitals requirement is very much important.
and not just the building and also the functional hospital. So what you have mentioned is initially when hospitals were designed, they were regular buildings. After that, because of the requirement horizontally and vertically, they were expanded, which made building more vulnerable. And another important point from your talk was that hospital safety index. So which we have to learn a lot. Actually, there are many things which we need to experience for learning, and many things which we need not experience, but from the experience of others, we should learn. So, earthquake disaster is one such thing because definitely in India, we don't want any such earthquakes, but we have to make our communities resilient by doing whatever it takes. So this is a period which is available to us to strengthen ourselves. Now, thank you, Hari. Now I'll move to uh, Mr. Jitendra from PIS. So, Jitendra, here is your question. How is the government ensuring compliance with the updated building codes, particularly in private housing construction? This is more specific to India, Jitendra.
Thank you, Pradeep ji, the CBRI. And I would also like to thank Dr. Jaraswati, chief scientist and head of the structure of CBRI for organizing this panel discussion and inviting us over here to discuss upon the since we have come from the country, Nepal. First of all, I would like to congratulate in CBRI for effort and for the work they have done in the rehabilitation of the water damage in Nepal. So, question which I have asked me. So, in this matter, I would like to inform that you know that India is under India publishes Indian standards as well as special publications, which are contained in that all the standards which are mandate are mandatory, not all. Most of all the standards are mandatory in nature. Now it becomes, and you know that construction is basically a state nature. So basically, the responsibility is basically directly owns to the government as well as the authorities which are involved in the inspection and regulation. So in this matter, the government basically shows as to the standards in the two ways. One is basically, I would say about the products, products and materials which are basically now innovating based upon the latest research and technological advancements. So, various ministries under the government of India, there is a quality control orders. So, these quality control orders basically give the mandates to the respective Indian standards regarding different materials which are to be used in the building construction. That is the first way the government ensures the mandatory compliance with the standards. And second, by making suitable reference standard documents basically for the construction projects. In those standard documents, they provide the reference to the respective Indian standards for the procurement, right from the beginning, from the procurement of the different raw materials, so that sufficient quality and safety should be ensured right at the beginning of the material is given. And thereafter, it comes to the construction and even up to the demolition stage also, because we have the demolition standard also. So that part is also covered under this reference document. Second is basically by giving the suitable reference in the building bylaws. Every state they are having their own building bylaws because every state they have their uh, specialized demographic features and soil and geological conditions. So they have their own building bylaws. So just like what Arun sir has mentioned that we have the National Building Code of India, which is a techno-legal document which not only provides the technical provisions but also the administrative guidelines under its part two. Basically, part two deals with the administrative provisions. So that, and I would also like to inform that Many of the states have already incorporated and included national building code provisions in their building bylaws. So third one is basically when we are doing the planning, basically every municipality, every town, they have their own town and planning acts, basically. So in those town and planning act, zonal plans, basically, and the municipal authorities, they also provide reference to the various parts of National Building Code of India, which governs the building construction and regulation in the country. And currently, our National Building Code of India, as Arunji has already mentioned, that it is currently under revision. The revision has been inaugurated in year 2023, January, and now by October of this year, we will be gladly release this revised document of National Building Code of India, and it's in its part six, basically. Part six basically deals with the structural design. So in this structural design, all the earthquake safety standards, wind-related standards, and all the landslide and site temperatures, all those provisions have been referred, included with the updated versions are already given over there. And here I would also like to mention where what Dr. Hari Kumar sir has just raised one very important point, basically, that was also under consideration in our technical committee for a very long time. So, sir, I would like to inform that in the upcoming release of IS 190 Part 1, there we have included one very specific section on the protection and safety of the non-structural elements. Our CED 39 technical committee, they have given the name as architectural elements and utilities. So there we have covered all the different attachments, appendages, and how do we ensure their safety that during the earthquake events, it should not fall from the walls or ceilings. All those provisions have been introduced in this revised version of IS 1893 Part 1. And it will also be covered in 1390, that is the design document. So this
new standard which as part of IS 1893 which got released, that is architectural units and architectural elements and utilities in the form of standard. So thank you very much, Stendra. Now over to architect S.K. Negi, who was also the part of this project of Nepal rebuilding, which was taken by CSIR-CBRI, for which Dr. Ajay Chaurasiya was PI, and architect S.K. Negi also contributed significantly. Now, here is your question, Negi. To what extent has retrofitting being carried out on heritage buildings and critical infrastructure facilities since the earthquake? And what are the challenges which still remain?
Okay, thank you, sir. Today, like everybody talks about 2015 is Yotha earthquake. If we see in terms of like the learning for architects and engineers, it was huge. Like it in this actually earthquake. Actually, if we see in Nepal, almost 78% of the population still lives in rural area, and 22% of the population still lives in urban areas. And the kind of devastation it took place, it was more towards the rural area, and the kind of geometry and the architecture, vernacular architecture, it exists in Nepal is basically on the vernacular style, and the material used is either stone or and timber. Because of that, actually the kind of the devastation took place. It was huge in rural area, and there is actually, as my previous speaker said, there all design options and the technologies are there. But we have to see our traditional wisdom is also required to see whether how to integrate that traditional wisdom with the modern systems. It is an important part. Now coming to the question, what sir asked me, like how many these heritage structures have been destroyed, yeah, got suffered during that 2015. It was reported more than 700 structures near Kathmandu and its around its valley. And out of that,
around 30 to 35% has been either recovered or restored. And majority of the structures which I was going to the literature, either these were UNESCO sites, World Heritage sites. And coming to the another is social infrastructure like school and health buildings. Since we were involved in this architecture design, I was involved in preparing the architecture design of school and health buildings. In that, actually, we have tried to make it more resilient. Actually, we architects believe in more fancy style of architecture buildings, particularly in this actually like if we are designing anything, if we are designing as a team in this actually structure architecture and the MEP services like professor said, there are some hospitals which were out of function due after the earthquake. That has to be integrated at one time. Now coming to the challenges, like first challenge is like we don't have the financial resources to cater all the damages which happen all across the Nepal. And second is the quality manpower, which we don't have. We need to skill the people. If we have to take the database of any heritage structure, which is very complex in nature, because we don't have the database, because creating the database takes a long time. So these are the some of the points. And another important point which is still left is like it should be made mandatory to the all architecture and engineering colleges in a syllabus, particularly civil and architecture, that how to retrofit the buildings and how to collect the database. These are the some of the points that I wanted to highlight. I hope I answered your question.
Yes, Nikiji, you scored full marks. Yeah, now coming to what Nikiji has just now mentioned, very important point because Nepal has many heritage structures. So let me give you my perspective of what is this heritage structure. If one generation has to transfer its knowledge to another generation, it happens through parenting, that is number one, and it happens through academic institutions. But now when it comes to society, how the tradition is carried forward. So their heritage structures play a very crucial role in transferring the knowledge from one generation to another generation. As Negiji has mentioned, so around 78% of people are in rural areas, and also there was a strong traditional knowledge, and this is clearly visible in terms of vernacular architecture using stone, timber, and mud. And also he mentioned that there were 700 or 700 heritage structures, and many of them or most of them are UNESCO certified. But till now, over 35% of those things were retrofitted and recovered. And mainly because of two challenges, the rest of the things could not be able to achieve. That is, first is financial resources, and second is quality, technical, training, human resources. So these are the two very important things. And the same we are also suffering in India. And he has given in a way one solution that this has to be integrated in our education system to prepare next generation. So thank you, Negiji. You've touched upon very important points. Now, I would like to go back to Professor CBR Murthy sir. Sir, yeah, you are able to see you on the screen. Oh, sir, here is your question. What infrastructure sectors remain most vulnerable today, and what long-term steps and investments are needed to address them? You, sir, please give your answer with reference to India as well as Nepal. Sir, over to you.
Thank you, Pradeep. With 10,000 municipalities and nobody checking safety of structures in the country, there is no need to worry which one is vulnerable. Virtually all the development, all the built environment seems suspect right now. But pointed question was on infrastructure. So I pick three items which are considered to be center, space for post-earthquake actions. First is transportation infrastructure. Our bridges, which are from the roadways as well as the railways, have to be examined quickly, assessment, and then retrofit of the bridges. That's the first one. Second one is water infrastructure. The pipelines that carry water long distances, as well as the elevated water tanks. Third one is power infrastructure. We're looking at substation buildings, switchyards, and the high tension lines that are going across the country, especially those crossing the faults. This is the backdrop, the fundamental three. Without transportation, without water and power, we will be crippled in the road after the earthquake. But what is crucial is, how do we do it? First, the Bureau of Indian Standards has to rush and quickly finish its 13935 series related to these infrastructure elements, which is assessment and retrofit of structures. In that, there are 5 levels of assessment. The first level is the field assessment. That I think is the most crucial, and we should be able to rush that quickly through the Bureau of Indian Standards. In the long run, we need to complete the retrofit standard also. And when I say long run for BIS, the long run cannot be 20 years, it will be 1 year only. In this next year, we have to finish. But when I come to high tension lines, we don't have a standard yet for earthquake perspective. But we have to come up with the assessment and retrofit urgently. The next item is that there needs to be a deeper understanding in terms of future built environment. So we can't make these mistakes again. I think there is a need for a detailed R&D to be put in on the bridges direction, as well as water tanks and pipelines direction. These three are seemingly absolutely crucial because we haven't done enough research on these three as far as full-scale testing is concerned. So we need to build test capabilities in the country as well as do the test for retrofit, because bridges are zero redundant structures, and hence we require full-scale testing to make sure that the retrofit scheme being proposed is actually effective. So that is the one long-term pointer I wanted to add here this morning. I'll stop here and then see if there are any other thoughts.
Thank you, sir, for your crisp and yet very insightful answer and comments. So just to summarize, you mentioned about three crucial infrastructure items. One is transportation, especially bridges. So you asked for assessment, quick assessment and retrofitting, and then water infrastructure, and then power infrastructure, particularly referring to high tension transmission towers. And also you gave reference to the upcoming document which is going to get released soon, that is 13935, and all the levels, that is level 1 to level 5 assessment procedures. In reconstruction process, this question is from Mr. Suraj Kumar. So this I'm asking Shri S.K. Negiji. The question is, how was the local capacity strengthened during reconstruction process? Hello.
Yeah, actually local capacity strengthening is like in CBRI, what we are doing is with the state governments. What we are doing is like particularly if we take the repair or retrofitting part of it, what we are doing is we are talking with the state government and we are capacity building of that engineers of that particular area, so that whatever work it will take place in that area can be done properly with the help of the experts from CBRI. We are taking the proper classes from in CBRI, and even we are going to the different sites, location of the sites. There we are giving the practical exposure how to do the repair and retrofitting, so that the capacity building can be done and it can be implemented in a better way.
Thank you, Negiji. Now, the next question is to Shri Anup Karan. To what extent were communities involved in the design and reconstruction of public buildings?
Okay, I'll just so I would not have a full-fledged answer on that. But what I definitely know is that there was a training strategy that was adopted by NDRRA and the NRA at that point in time. And their whole idea was to actually build in enough capacities in the country. For that, I think a lot of approaches were taken up. There was no singular particular approach, but I believe that with the institutions like CBRI and others, there was a clear understanding of how to get that capacities built at multiple levels. So levels, when I mean, it is at the level of the local government, at the level of the approval authorities, at the level of the people who are actually doing the technical supervision, because the whole idea when you say community, it's a community of practice. It's not just asking a house owner to be ready to understand the aspect of earthquake engineering. It is also the engineers, the masons, the architects. And there is a report which actually talks about how this was done. I can't get into all the details, but there was a training strategy for reconstruction. It actually endorses the mechanism. This was laid on in 2016. It also has numbers, which looks at how many engineers, how many sub-engineers, assistant engineers, masons. All that numbers are very clear in terms of meeting to the technical requirements of reconstruction. Having said that, the community being at the core and the politicians and those kind of people who are also equally responsible in terms of being part of the whole reconstruction process, because as we know that vulnerability is not just manifested by people. I mean, it is also the entire system, which needs to be very mindful and careful. So the elected representatives, the government officials in 32 earthquake affected districts were part of the whole reconstruction process. That included not only buildings, but also included, other important structures which were to be reconstructed during the period of the last 10 years.
Thank you, Anup, for elaborate answer. Now, we have completed one round of questions to panelists, and we have taken some selected questions from the audience who are present online. Now, some 3 questions from the audience who are present here. So please feel free to ask questions. Yeah. They have understood. Yes, control. Yeah, Ashish, please go ahead.
So just one question I would like to. So we have heard everyone talk about what we have done about Nepal and how ready right now Nepal is all about, and how the coral provisions are currently going ahead for our country. But being said all of this, what you think that how much ready we are currently if something like this hits our country?
Yeah, anyone who is a taker? You want, please.
I think we are, what people have said, we are in a vulnerable state. The existing infrastructure condition and then the density of built infrastructures in major cities or even villages, because we love to live close to each other. But in hills, somehow say that the buildings are distributed in at a far off distances that they don't have. But even in hills also, the major cities, if you see this Josiphat or Simla or Masuri, you can see if one building collapses, it will hamper the whole array of the buildings in this. And in terms of preparedness, whether it is earthquake or landslide or multi-hazards, it's really the scenario is very, very upset. So that's why what Murthy sir has told, now we have to concentrate or even Yogan Singh sir has told, we should strengthen our existing infrastructures and no build for vulnerable infrastructure. That we have to be very, very serious about that.
Thank you, sir.
Good afternoon, respected panel. Sir, I don't have any question. I have only one request. At the beginning of this project, Nepal project, we all visited many districts of the Nepal, like I visited Tolakha. So my one request is to Ajay sir especially, if we can prepare a documentary with the experiences gained during the construction of the school buildings and library. Also, taking feedback from the users, that is the teachers or the school students, and to prepare a documentary and upload it on our website. Thank you, sir.
Yeah, thank you, Kaushik. One last question from the audience. Who is that lucky person? Mickey. Yeah, lucky person is Mickey. Good. Right.
Hello. Sir, after hearing the panel discussion, only one question I have. What I have observed, and I think our academicians, Talbot, who are in the panel, will agree, the overall knowledge of earthquake engineering per se, we say structural dynamics at graduation level is very poor in our country, other than the premier institute, if we can talk. So, what are the steps that we can take to inculcate the basic necessity and the urge among the BTech graduates or the engineers to consider this as one of the inherent and basic importance that this subject demands among the undergrads and young budding engineers, civil engineers.
Yeah, thank you, Mickey. I request Murthy sir to answer this.
This is a bomb. So,
sir,
see, first
education is, sir.
Yeah, I know. I'm saying the answer is a bomb. So, the worry is undergraduate students, undergraduate curriculum is coming down in its content as far as engineering is concerned. We have 7 courses out of 45 right now in civil engineering, which means that you can't achieve much in undergraduate. I pray that the other colleges don't take this route of what IIT is taking, and they will stay clean and have at least 50-60% of content or 70% in civil engineering. First. Second point is that, it is not happening when faculty members appeal to the higher officers, it is not happening. Bottom up is getting suppressed because these earthquakes are happening occasionally. What I think we require is some wisdom at the higher levels to ask at least a few colleges to produce graduates who are formally trained in this subject. I'm looking for a day when engineer in India says earthquake is displacement and not a force, and that has not happened yet. And for this, I would request Director Pradeep Kumarji to use his good offices and get some directive top down, because it is not happening in the last 33 years, at least in my existence in the academia, that anybody is listening to us in terms of implementing a long-term program. There was a small window when Professor Jain had pursued with the ministry from 2003 to 2007, where we managed to get some enthusiasm brought in, but somehow it disappeared. We need yet another national program on earthquake engineering, education, and research to bring back on rails the academia. First of all, with the teachers, we have to get teachers, then we'll fix the curriculum, then we'll fix the education program, then degrees, and then graduates. All this is 15 years lag. But on the other side, practicing engineers, I think they are the ones who require urgent help. And we need to address their requirement urgently. The institutes are very slow and sluggish, but I think if we can start a program to train practicing engineers and architects in the subject, that will be the fundamental step. It will make more impactful movement towards earthquake safety in the country. Thank you.
Thank you, sir. Thank you, sir. Dr. Hari, you would like to add a bit more.
Thank you, Murthy sir. And Murthy sir was very much involved in trying to get earthquakes and disaster management in the curriculum in CBSE itself. Sir, that is where we first met in 2002.
Right.
When we were writing a chapter on disaster management CBSE. With much fanfare, it was included in the curriculum. For 3 years, it was there. Then it became an optional subject. So there were no exams in disaster management. So that is where we lost that. It's still there. It is still an optional subject. They give some projects or holiday homework on disaster management. I feel very terribly sad because a lot of effort was put in to write this chapter. And as Murthy sir said, there was this NPEEE program, which really actually took up earthquake engineering education very seriously. It was followed by the Ministry of Home Affairs making 2 programs, one for architects and one for engineers, again for practicing engineers, training on the job training. But all those efforts have petered out. Not much is happening. And I can also, in answer to the question, also cite an example of IIT Kanpur doing an architect's contact course. I can't remember what it is called now. Every year, 4th year architecture students are brought to the campus, and 1 week of lectures. Professor Murthy included many eminent earthquake engineers talk to the students to inspire them. And I know many of them who have been inspired by those 10 days or 15 days of being in IIT Kanpur, who have gone on to take disaster management and earthquake engineering as a profession. So many efforts are on, but in a country as large as ours, nothing is enough. Thank you.
Yeah, Professor Yogendra also would like to add.
Because it is such a thought-provoking question for all the academicians. So I also have some, what should I say, radical opinion on that. And in my opinion, of course, all our programs for servicing engineers are necessary, and they have their role. We need to think about our formal education also, like the question was originally raised. So in my opinion, civil engineering has overgrown. So it is the oldest engineering. All branches of civil engineering have developed a lot. And whenever we are making a timetable or a course curriculum, there is a fight for slots from all the branches. So what I feel that there is time to bifurcate now, and we should have an undergraduate degree in infrastructure engineering or something like that, where we are focusing mainly on structure and geotechnical. And other subjects will have a little less doubt. Then only it will be feasible, because it is not only earthquake engineering. Structural design in general has degraded a lot in our undergraduate education, and we have to think.
Sir Yogendra, Dr. Hari, and Murthy sir for answering the question from Vicky. Now, one more question came up from the audience online. That is, what are the efforts which were made for assessing the risk of cities and towns, especially in the highly hazardous areas, and from the point of view of earthquake and other disasters? So I'll ask Charasya to address that.
Thank you, sir, for the beautiful questions. As regard, so this basically question also addresses to the concern raised by Mr. Anup and as well as with Dr. Hari regarding the risk zonation in India. So I would like to mention here that the NDMA has taken a very proactive role in this. They have identified two programs. One is on development of risk of a town. 6 hilly towns have been taken in Uttarakhand and Himachal. And in other vertical, what NDMA suggested to take a multi-institutional project with wherein CBRI is coordinating and other 5 IITs, namely Madras, Guwahati, then Roorkee, and uh, I think this and Mumbai. So these IITs are participating together. Efforts are being made to create a methods for risk assessment of a buildings and a town. In contrast, when CBRI has taken it over and now we have finished this particular assignment, wherein we have adopted the procedure given in IS 13935, as well as we developed few fragility curve in terms of Indian construction practices. Based on that, we could finish the risk assessment maps for towns, 6 towns, which basic, and for that purpose, again, we have taken help of IS 1893 2025 is a draft report, which suggests that the Indian Himalayan region is ranging from 0.6 to 0.7 GPG. So we have developed this risk assessment map ranging from zero point 0.3 to 0.7 PGA at the regular interval by carrying out different non-dynamic analysis and then fragility curve development. And thereby we have assessed and developed the GIS-based map in a grid of 250 by 250 meters for a town, wherein we have pinpointedly mentioned that what is the loss of life, loss of casualties or injuries, then what will be the economic losses, and where should the important facilities like hospitals, schools, and resilience centers should be located. So I think this kind of effort is a pioneer in future. And if this method is accepted as a tool to NDMA, that can this method can be adopted in larger scale, scalable for across the country. So thank you so much. Yes.
Bit quick. So just to echo the fact that risk assessment as a subject has been pushed very hard in the last 20 years. There's a lot of risk assessment being done in the country. So the state of Uttarakhand currently has a risk assessment done for the entire state. It covers all the hazards. It covers all significant downs. This was also financed post the 2013 big floods that happened. So you have this information for all major hazards, but the important aspect is that it goes down to infrastructure level. It has the fragility curves. It also gives you a sense in terms of assets at risk. It also then talks about the economic values. But what is very important is that these kind of risk assessments become very much driven for a very particular timeline. Getting it updated requires a whole lot of institutions to come and participate. The good part about another effort which was done by NDMA was for the entire coastline. So entire coastline which is subjected to cyclone risk, the government of India had 2 phases: National Cyclone Risk Mitigation Project 1 and Project 2, which spanned over almost 12 years. In this process, what they essentially did was they brought all the key national institutions together. They included IMD, NIOT, NI, included INCOIS. So all these institutions actually prepared a generation of hazard information, and their information comes at different time scales and time horizons. The modeling efforts that they do is something that cannot be duplicated. So the Web Dynamic Composite Risk Atlas is a dynamic atlas which actually kicks on the onset of a depression in the ocean, and from there onwards till the landfall happens, and landfall plus 2 days, this entire system runs around the clock by bringing all these institutions together on a common platform, which is operated at the level of Indian Meteorological Department. And the National Disaster Management Authority was actually the key agency managing this whole effort. What it does is it brings all the data sources of the government on a common window. Because sometimes you don't get a DEM, you don't get a good hazard map. But that is not the case when the government institutions comes together and makes it as part of a larger collaborative effort. In that particular assessment, what you have is risk which is informed at a real time. Because when the cyclone comes and hits the coastline, you may have 3 hazards working together. You may have wind, you will have rainfall, you will have flooding, you may also have dam release action, and you also have the storms that happening together. Now, for all these things to be calculated on a real-time basis, and also to make sure that you evacuate, I think the point what we touched upon is whom are you going to evacuate where? So the zone of influence, the zone of risk is calculated real time. In fact, you get it like 5 to 6 hours in advance. And based on that, evacuation plans have been done over the last 8 to 9 events. I was part of that team. So we did that for 8 experimental events. In the sense, experimental is real events, but at an experimental stage. It is an operational system right now running in NDMA.
We need similar systems to be done for flash floods, seismic events. On an onset of an event, what we have currently is just, one shake map, what comes from the NCS. That is not good enough for us to basically take any decision in terms of what could be the potential outlook, till we get to know it after 2 days and after flying all the drones and getting the satellite imaging. But I think what is required is dynamic risk information. And I think for that, a lot of work. I really appreciate the point that you said, more than what is being done now, need to be further brought into a common window so that the next risk assessment doesn't start it from the scratch. What I have as a bigger problem to see in the last 20 years of my effort, in this field is every time there is a reset button somewhere the system, we restart the whole process again because the data is lost, the data is not available. 5 years down the line, there's a new program that comes from somewhere, and then we figure out there is no map available. And I and Hari were part of doing some similar work in Assam. We wanted to do the electrical system assessment. We wanted to know what will happen if a particular earthquake strikes. There's so many historical earthquakes. If it strikes Guwahati, how your entire electrical infrastructure system is going to behave. So we've got back to the seismic microzonation work, which was done in 2004. We got that. We had to digitize it, unfortunately, because we could not find the shape files and everything. Digital
almost at the closure. So I have kept some rapid questions to be asked to the panelists, but most of the questions are addressed except 4 questions are remaining. So these 4 questions I'll point to. First one to Dr. Srinagesh, and the second one to the SK Negiji, and third one is to Mr. Arun from BIS, and fourth one is Professor CBR Murthy. So these are the 4 pointed questions, and I request very brief and crisp answer to these questions, and after that I'll wrap it up. Now the first question to Dr. Srinagesh is, so now in India, IS 1893 new hazard zonation map is coming. So now the question is how people will embrace it and also put that into practice while designing of buildings. So because there is a general feeling that acceleration values are enhanced. Dr. Srinagesh. Is he there? If not, then I request Professor Rupen to address this.
Okay. Two aspects very quickly. Of course, the acceleration values will look enhanced because you can look at it in 2 ways, that the new values are more than the higher values, or we can say that earlier values were probably underestimates. Whichever way we look at it, the fact remains that there is a new hazard and it will have to be used henceforth. But what is interesting, and I want to just step ahead of time and talk about, is that this is, again, we are looking at only the so-called far field effects that we consider in design. What we have seen, particularly Nepal earthquake and some of these ranges, the Himalayan ranges, we are going to see near fault actions. And that is still not part of any design standard, I mean our design standard. So that is something that we will probably be looking at in near future, and I hope it happens, because some of the things, when you talk about seismic safety of structures, considering near fault effects in those regions will be important, and that is something we have to get to.
Yeah. Thank you, Rupen, for the quick, crisp answer. Now, over to Negiji. So, Negiji, how we can take into consideration two together? One is aesthetics as well as resilience.
Aesthetics versus resilience, actually.
And resilience together.
Together. Like aesthetics, actually, so for architects, like for us, aesthetics is actually, we consider it's a more distinct benefit for the architects, because when we have to showcase any project to the any client, so the client sees what are the actually how it looks, so what is the beautiful features and all. But in terms of like resilience, if like I should rather say like we should not compromise on the resilience for the cost of aesthetics. That is my answer, because being working in CBRI, this, this is actually in the last 30 years, what I feel is like resilience is more important than aesthetics. Actually, in practicing, it is just reverse. If it is even the civil engineering, if if the practicing architects and civil engineers, what is they are doing, the architects are giving some plan to the civil engineer, and as per the requirement of the architect, the civil engineer or the structure engineer do the complete designing, which is the wrong practice. What I feel is we should give first priority to safety. If our life is not there, then this aesthetics and this will not last more. Thank you, sir.
Thank you, Negiji, for very good answer to the question. Now over to Mr. Arun.
Yeah.
Please point out three biggest barriers in achieving code compliance in India.
Okay. Three biggest. Okay. I think the first question has already been answered in one of the presentation in the earlier part of time, because every building design which is being submitted on behalf of the owner goes to the authority, and it is expected that the authority is verifying it or checking it before it gives a permit for construction, and then during the construction, and then finally an occupancy permit. We have to revisit whether all the states and UTs in the country do have that manpower. In case there is a severe shortage, it's not in case, it's typically largely we are seeing. What are the tools and what are the solutions? Can we leverage the IT tools? Can we leverage the softwares? Can we leverage other big tech to find out whether the compliances are there? But I think the answer is not really true. Even in USA or any other developed country, all the structural design calculations, at least for the lateral load resisting elements, are checked by a third party. So that concept is now being introduced in the National Building Code in its Part 2 administration, that as well as in Part 6 structural design. So that is meaning that any building which is going to be on, even on a seismic zone 3, 4, or 5, people are supposed to do the proper detailed structural drawings. Second thing is, I would say it is social aspect. People should not fall for claim from manufacturers that a material is earthquake resistant or it is a high super strength, etc. Rather, the owner or that particular engineer or an architect should go and ask the specialist structural engineer whether the claim with respect to material is going to really help my G plus 10 story building or a G plus 2 story building or a G plus 7-story building. So that openness in discussion from the owner with the structural engineer is important, which means a structural engineer should be employed and not just an architect alone. Gone are the days where we simply have only an engineer or an architect who can do everything. Today, the options of materials is plethora. I mean, too huge, and more importantly, the hazard. And Mr. Anup also just now mentioned about multiple disasters coming in one time. So we should consider them also. Of course, any standard would not ask you for all the combinations, but prepare for the worst. And third one, I would say, with respect to another, I would say with respect to the social only, when it comes to infrastructure projects or huge buildings or projects, the engineer in charge of the project manager, chief project manager, should be consulted before even an inaugural ceremony date should be given to a project. Rather, they should see that the CPM per chart, etc., whether the proper construction period is being given even for a construction of a toilet or for a foundation or for any structure, because there are incidences where projects have failed miserably because of cutting corners in terms of time. Rather, that decision should be taken by the chief project manager. I'll stop here because I think three options, I gave three options, which I felt is quite important, seeing the number of failures.
Thank you, Arunji. Now, this is a last question to Professor Murthy sir. Sir, what are the policy level gaps which need to be addressed to achieve earthquake safety in the country? मुझसे नहीं है. So I request Professor Yogendra Singh ji to take that question.
At policy level, first of all, we have to mandate the structural safety as part of the contract. So, although it is coming indirectly, codes are part of the contract and those are being implemented, but the willpower to do that or the system is not strong enough to implement that. So first of all, it has to come from there. And secondly, second thing is that our implementing agencies who have to ensure structural safety, those are not having enough capacity. So capacity building, we have been doing it, but somehow we are not able to achieve what we have to do it. So we have to work on that policy so that those agencies are having enough capacity in terms of manpower and also in terms of skill. Our agencies are lacking on both these points. Enough manpower is also not there, and somehow we are going in the reverse direction currently because the capacity was coming earlier from mainly from government departments, state government departments and central government departments. Now we are working in project mode. So the problem with project mode is that whomsoever we are hiring for the project duration, uh, that manpower goes to different places and start doing different things. So somehow the capacity of the government department permanent employees who will remain there for long, that needs to be enhanced. So I think these are the two policy gaps, most important policy gaps in my opinion, which should be taken. Thank you.
Thank you, Professor Yogendra. Now we have come to the end of this panel discussion, ruins to resilience. So truly speaking, the kind of answers which our august or esteemed panelists have given is filling with the hope that yeah, we are becoming more and more resilient, and the journey will continue. So I wholeheartedly thank the esteemed panelists. So Professor CVR Murthy, Professor Yogendra Singh, Professor D. Srinagesh, Professor Rupen Goswami, Mr. Arun Kumar, Mr. Jitendra Kumar, Dr. Hari Kumar, Mr. Anup Karan, Architect S.K. Negiji, and Dr. D.P. Kanungo, and Dr. Ajay Chaurasia. So just to wrap it up, as we all know that disasters are not affordable. So we need to work very hard to achieve zero tolerance. Now, let me say that we have to go beyond that. So three things we have to achieve. One is life safety. Second one is uh, no property loss. And third one is no business loss. As India is marching towards Viksit Bharat, the ambition what we have put to ourselves, and all of us have to contribute towards that. So by 2047, we have to target this. So we have three main challenges, that is no life loss, no property loss, and no business loss. So with this positive note, I close the panel discussion and hand over the mic to Ashish for taking it forward.
Thank you, sir, and thank you for this very insightful session. And I hope everyone listening to the thoughts that has been shared over here would definitely start thinking in this direction, if not till now, and will start delivering their bit in this week. So with this, since we have proceeding towards the conclusion of the session, I would like to request our director sir to please, as a token of appreciation, I would like to request you to please give mementos to our present mementos to our guests. So, sir. Thank you, sir. Now, so, sir, now I'll request Negi sir to please put up. Sir, please.
Thank you, Ashish. Namaskar. Good afternoon to everyone. I have assigned the duty to propose both of things. First and foremost, I would like to extend my sincere appreciation to all our esteemed guests, Shri Krishnawatji, Professor C.V. Murthy Professor D. Shri Ganesh Professor Yokesh Singh Shri Arun Kumar, Professor Rupen, Shri Arun Kumar, Mr. Jitendra Kumar, and Dr. Hari Kumar for gracing this occasion with their presence and sharing their valuable insight. We are really thankful to you all, sir. I am also thankful to our director, CBRI, Professor Pradeep Kumar for his constant support and help. My special thanks are due to Dr. Ajay Chaurasia, Dr. DP Kanungo, and the entire organizing team. I am thankful to all. Hello. I am thankful one and everyone, those who are contributed to this one day, a half day panel discussion. Once again, I thank you all for contributing this half day panel discussion that is linked to resilience. Thank you. Thank you very much.
Thank you. Now, request everyone to please resent that as specifications for the national activities. Thank you, everyone. Now I'll request everyone to please join us for lunch. at the meeting hall. Please. Thank you.